Hi, scholars. Today's lesson notes are 4.5. They're due tomorrow, and they are very brief on segments in triangles and the types of segments in triangles. So, of course, as you can see, Unit 4 is all about triangles. And so this particular lesson is about the segments that you find in triangles. On Friday, we're going to actually be doing constructions with triangles. And so you'll notice there are going to be certain sections that are not filled out of these notes because we're not doing them yet. We're doing them on Friday, either this Friday or next Friday, depending on when you have me. So for this lesson, you're going to be defining, sketching, and identifying medians, angle bisectors, and altitudes. And then on Friday, you're going to be able to construct medians, altitudes, angle bisectors, and perpendicular bisectors. You already know how to do this already for perpendicular bisectors and angle bisectors, but now there's just going to be an actual triangle, not just an angle. So the first definition: within a triangle, all of the following types of segments must have an endpoint at one of the vertices, okay? So of the three that are listed here, they all need to have one endpoint on a vertex. And we know the vertex is the point where two segments meet. So these are your vertices. And for all three of these segment types, they all have a vertex of, an endpoint on a vertex. So for example, the first one is a median. So that's what we call a segment that has an endpoint on a vertex, and its other endpoint is on the opposite side, and the midpoint in particular of the opposite side. And so this is your midpoint right here. Okay, but your median, and it's really important to remember this, your median splits your midpoint into, or rather splits the side that it intersects into two congruent parts. So again, a median goes from the vertex to the midpoint of the segment on its opposite side, and this here is the specific definition. An angle bisector is it is a segment that, of course, has one point on a vertex and the other goes to the opposite side, but anywhere on the opposite side, not specifically in the middle or anything like that. So if you do have an angle bisector that has its other endpoint on the midpoint of the opposite side, it's called a median. That's also an angle bisector, okay? But the angle bisector always touches a vertex, or it always has an endpoint on the vertex, but again, anywhere, its second endpoint is anywhere on the opposite side. What's unique about a segment that is an angle bisector is, of course, that it splits the two angles at the vertex into two congruent angles. So it basically bisects whatever angle it intersects at the vertex. Okay, so what you need to know about a bisector is that it makes congruent angles at the vertex. So if I had my endpoint here, my angle bisector had an endpoint here, it would split this angle right here into two congruent parts. So here's the definition: a segment with endpoints on a vertex and the opposite sides such that the vertex angle is split in half, or two congruent parts. Then we have the altitude. So the altitude is a segment that is perpendicular, has an endpoint on the vertex, but its other endpoint is perpendicular to the opposite side. So it intersects the opposite side or touches the opposite side to make a 90-degree angle. And so that's what's really unique about the altitude. And it also, this segment right here literally measures the height of the triangle. So if you're trying to figure out the height of the triangle, you would need to know what the altitude would give you that value. If you're trying to figure out what is the distance from the vertex to the opposite side of the of the vertex. So if you think about this is the highest point of the triangle, the opposite side, this segment between that highest point on the opposite side is your altitude or your height. Another word for altitude is height. So let's talk about that definition. It is basically a segment with endpoints on a vertex and the opposite side that is perpendicular to the opposite side. The altitude also represents the height of the triangle. So then we get down here to the perpendicular bisector, because the perpendicular bisector is also a segment that is found in triangles, okay? But the unique thing about a perpendicular bisector is that it does not have to start at a vertex. It doesn't have to have an endpoint on the vertex, okay? But what it does do, because it is a bisector, is that it splits the segment opposite in half. So I'm going to measure this segment, and let's say it's about 4 inches. It's not an exact measurement. It's a little, right, it's a little less than 4. But we're going to say that it's 4, and we're going to say that this right here is your midpoint, or that's half. So your perpendicular bisector could literally look like this, right? So, and then it would split these in half. It is a perpendicular bisector because, and then if it also, right, intersects, so that the side that is intersected is a 90-degree angle. So this would be considered a perpendicular bisector because, once again, it splits side CB into 2 congruent parts, and it creates a 90-degree angle with CB. So like I said, your perpendicular bisector can literally come from anywhere. It does not need to have an endpoint on the vertex. Okay, so it says here, the perpendicular bisector of a side of a triangle is typically not the same segment as the median. Okay, that's important to remember because, remember, the median also intersects at the midpoint of its opposite side. Something that the median and the perpendicular bisector have in common, but they're not the same, okay? Or it's not the same as the altitude. Why? Because the altitude always has to have a point on the vertex, much like the median. All right, so just make sure you have that information. The perpendicular bisector is something completely different. All right, so the next thing you have to do is the try it out. Do not worry about section 4. Just do the try it out. And let's do one together. I want to find this one, the altitude. Where's the altitude? So name examples of the following. So I'm looking for a segment that starts at the vertex, that has one endpoint on the vertex, and then intersects a triangle to form a 90-degree angle. So let's find that. All right, and so that's question C. Well, if I look at EG, this segment here, right, has a point on the vertex, its other point is on the opposite side, and it forms a 90-degree angle. So this would be an altitude. Okay, fine. Go ahead and do the rest of them yourself. And remember, if you have any questions, just reach out. All right.